Hello, welcome to Algebra 1. Here we are at the beginning. Oops, not quite. Boom, there we are at the beginning of Notes 5 within the first learning target. We're talking about functions. Today we're talking about story problems and how to create functions out of situations. Let's begin. There we are back at the beginning. Here we've got a first example. It says a local youth group is planning to take a trip to a local amusement park. They're taking a bus, which holds 32 people. It will cost $30 for parking, and tickets to enter the park are $50 per person. First order of business, carefully define two variables in the situation. As you can see, I got excited and started underlying this people concept, so I'm going to go ahead and make P be the variable for the number of people on the trip. Now, additionally, it says it will cost $30, so I'm going to go ahead and let C be the cost for the trip. Those are our two variables. Now, there's no reason why you should choose P for people and C for cost. It makes sense to most people. Some people just kind of go with X's and Y's, or some people just go with their favorite letters, perhaps their initials. It doesn't really matter. Okay, I'm going to use P's and C's. Next order of business, identify the independent variable and the dependent variable. All right, so first of all, the independent variable. This is the thing that changes the inputs of the situation. In this case, that's P, because the number of people going will affect the cost. And that means the dependent variable is going to be C, because that's the cost. All right, so the cost is going to depend on the number of people on the trip. That's what that means. Now here, I went ahead and I left the wording of the example on top and then the rest of the bullet points there on your notes. Write a function to model the total cost of the trip. Well, let's see here. The cost, which is based on the number of people, is 30 plus 50 times P. So C of P equals 30 plus 50P. Now, if you don't love that C of P stuff, you can go ahead and write C equals 30 plus 50P. It's not quite as good, though, and so that's why I'm going to say C of P equals 30 plus 50 times P is the better answer. C equals 30 plus 50P, that's okay. Not amazingly insightful, but still pretty dang good. All right, now the domain. The domain, of course, is the set of inputs that are possible. And we know the bus holds 32 people, so you could have 0 people, 1 people, 2 people, 3 people, blah, 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 all the way up to 32 people. I'm sorry if you were hoping I would write a set with 33 numbers in it. I didn't. Okay. The range is the set of outputs, the set of costs. So we have 30 for 0 people, 80 for 1 person, etc., etc., etc. And as you can see, we've got a pattern going up there, so I cheated and did some ... dots. I figured out the maximum cost. Yeah, we're in business. And then just to really help you understand what's going on with this range, I went ahead and I wrote down the number of people, 1, 2, 3, 4, that went with each of those numbers in the range. But that's not the answer. The answer is the stuff in red. The stuff in blue is meant to help you see it, except now I see that I've made some mistakes. So I'm going to go ahead and fix them here. Pachoom, 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 pachoom. These numbers are wrong. Instead, that would be for 1 person. Oh, did it again. 0 people, 1 person, 2 people, and 3 people, and then etc., 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 all the way up to 32 people. So, apologies for the mistakes. Everybody makes them occasionally. The lesson is, of course, you got to try to bounce back. Okay. But again, the answer is the stuff in red. That's all for example 1. Now example 2. A pizza shop charges $10 for a large cheese pizza, plus $1.50 for each topping. The shop offers 10 toppings. First of all, we have to carefully define two variables. We can go ahead and let n be the number of toppings. Again, no reason why you should have to choose N. I did. And C is going to be the charge or the cost of the pizza. Okay, independent and dependent. Here you want to think about what depends on what. And in this situation, the cost depends on the number of toppings. So the independent variable is going to be N, and the dependent variable is going to be C. Because the cost depends. So the cost is dependent. The cost depends on the number of toppings. All right. Here next we got to write an input-output table for the total cost of pizza. And I got excited and I go ahead and made it for you. The problem says there's 10 toppings, so I made a table where the number of toppings could go all the way up to 10 from 0. And then for 0 toppings it's $10, like it says. For 1 topping it's $11.50 because it's $1.50 for each topping. For 2 toppings, it's $13, another $1.50. For 3 toppings, it's $14.50, another $1.50. And then you keep going, adding $1.50 for each extra topping. Really sure who wants a 10-topping pizza, but whatever. Okay, so there you go. This is kind of annoying. We didn't do this in the last example, but it'll actually sort of help make the other stuff coming up easier. So, explain why the relation shown is a function. Again, I included the wording of the example above, but it's not on your sheet because your sheet all works at once. Okay, explain why the relation is a function. Okay, so it's a function because each value of n goes to a certain value of c. And what I mean by that is if you know how many toppings there are, you know exactly what the cost is, because there's a rule for how you get to the cost from the number of toppings. Now the domain, remember, domain is the list of inputs, the list of the independent variable options, and that's 0 to 10. And the range, which you could spend your time thinking about all over again, or you can just copy from the table before. 10, 11, 50, 13, etc., 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 all the way up to $25. Okay. That's example 2. Now we move on to another thing that's going to happen here, which is not going through that whole rigmarole, but just looking at a situation and explaining whether it makes a function or not. So for example, 3. The input could be the number of letters in a student's first name, and the output could be the number of letters in a student's last name. And that is not a function, and that's because people can have the same number of letters in their first name, but different numbers of letters in their last names. So knowing how many letters are in somebody's first name does not tell you how many letters will be in their last name. My name has 3 letters in my first name and 7 letters in my last name, and not everybody with a 3-letter first name has 7 letters in their last name. For example, last year in Algebra 1, in this one class, I had 3 guys named Sam. Not even the same letters, just the exact same first name, but their last names all had different numbers of letters. All right, so that's example 3. Here's example 4. Tell whether your height is a function with your weight. And the answer is no. And that's because if you know your height, there's no way to convert that into figuring out what the person's weight is. And more specifically, you could have the same height, but you could change your weight. And just as a couple examples, think of after a long workout, in which case you often weigh less, just mostly because you've lost a lot of water. Or after like a Thanksgiving dinner, where you're not any taller or any shorter, but you are a lot fuller. And then you could, you'd weigh more. So that's another example of something where the situation is not a function. One more. Your age in years and your height on your birthday. Not your height all year long, your height on your birthday. And this is a function, because once you know how old you are, at least in the past, you can figure out how tall you were on your birthday. There's no magic formula for it, but there's only one height for your birthday that goes along with each of your ages. So this is, in fact, a function. Okay, this is some tricky business, trying to take these words and turn them into symbols, and then these last three examples, taking the words and noticing just with the words, not with the math symbols, whether a situation is a function or not. So please let me know what your questions are, and thank you for watching.